Make sure it gets started. All right, so we are live. Okay, so here's what I need you to do. Y'all ready? Okay, so I need for you on your piece of paper right now to draw a pair of parallel lines.
Doesn't matter which way?
Nope, doesn't matter which way. Now let's talk about how you're going to make sure they're parallel. What are you going to, Okay, but how do you make sure that they're really, truly, honestly parallel?
Use a ruler. Either side of the ruler.
That's the smartest way to do it, right? So take your ruler and draw a line on both sides without moving that ruler. That's the easiest way to make sure that your two lines are parallel. See, y'all see that? Are you okay? Okay. So we've got us a set of parallel lines. Let's call them line. Let's call it line L and line M. Any guesses why I called them line L and line M? That's my initials, because I'm a big nerd. You can call them whatever you want to. Okay, now you're going to take your ruler and you're going to lay it any way you want to except straight up and down. You can make any angle you want to make. It doesn't matter what angle you make. Any angle you want. Any angle you want. And you're going to draw a line that goes through both of them completely like that. Y'all see that line right there?
Wait, I just really like you doing that.
It's okay.
I'm going to do what you do.
Now you've got to make sure you've got two parallel lines. Two lines that are parallel to each other. That are far enough apart. I mean, at least ruler width apart, because we're about to explore some angle measurements. Okay? I got to thinking, I'm going to get close to you in a minute to see what your nose does. I put on some lotion the other day, a couple of days in a row, that had sesame seeds in it, sesame oil in it.
Oh, that makes me tired.
Well,
My nose.
yes, because the other day your nose would run every time I got close to you.
Oh.
I think maybe you might have been allergic to that lotion I put on.
Can you eat like hibachi?
Me?
What is hibachi?
Yeah, I can eat hibachi.
Oh, yeah.
Like
I
a
want you to
sausage.
learn sesame oil because that's in hibachi.
I'm sausage.
It's true.
What is sausage?
She may not be.
Yeah.
Yeah, I was just going to see if your nose ran. Because I don't wear perfume, so it couldn't be like, I don't ever put on perfume. But I did put on some body lotion that was sesame oil based. And I only did it one day this week, and it was that day that your nose was running.
I'm down for that.
I thought it was like on my nose.
No. Okay. All right. Now, here's what I need you to do. Everybody listening to me?
Yeah.
Take your protractor. And I want you to measure every angle that you just created with those two parallel lines and that line going across them. So measure every single angle. Be as accurate as you possibly can. Okay? Now let's, as a reminder, remember when you're measuring an angle, you're going to put the vertex right in your little circle or right on your crosshairs, however your protractor is set up. Make sure that this line on the protractor lines up with the line of your angle, and you measure from whichever side. You have to start at 0 to measure, right? You probably are going to need your ruler to lay it along that line that you drew so that you can see what the angle measurement is. So like my angle right here, this angle that I'm measuring, I'm going to start here. It is 103 degrees. And I'm going to write that number right inside that angle. 103 degrees.
Wait. If I look at it, you measure the other one?
I measured this one right here. I measured that one.
Oh.
And then I'm going to put my protractor back there. I'm going to put it right back where it was just a second ago. Right? And I'm going to measure this other angle. Make sure I've got that laid down right there. As accurately as I can make it. Try to be as accurate as possible. I'm measuring from the inside numbers this time. And so that's going to be 70 5, 6. I think it's 77. I think I've got that.
Mine is 55 degrees. Mine
and
was
25 degrees.
75, so I don't know.
Okay, but measure all of them. So how many angles should you be measuring then?
4?
8. How are there 8 angles?
Oh, one here. Wait, how would I do that?
So measure all of those angles.
So how would I do that? I'll grab it.
So how are you going to measure it? Won't you try? Try. Let's see how you do. Then you'll find out in front of it. I know. You have them all 8 measures? If you actually measure all 8 of them?
Can I do that?
Yeah. Yep.
Would I just do this one? At all? So I'm gonna do. Well, I'll do this one.
Wait, let's go back.
Okay.
Um,
Nah. 78.
you want to measure? You measure all of them? I'm real, you're behind. What do you think the name of
Bro, all these are the same.
Okay. I know not everybody has got all their angles measured yet, but does anybody want to show their paper while we're waiting for everybody to get finished? So you can go lay it up underneath the document camera. Paul, do you need help? I need help. I'm trying to figure out the wrong way.
There we go.
I'm moving the paper too.
No, it's
Okay, what
55.
55.
You only have one? Well, you have two down here. Two here, two here, two there. Do you see them? Yeah.
I don't equal one in.
This one, does that look like a 65-degree angle to you? Okay, but remember, you're starting on this side. You have to start measuring at 0. That's one of the things number starting. Yes, sir. What?
Is it your mom? Or is it? Wait, I go for rescue.
Yes. Okay, look at rubies. Do y'all see rubies? Take it all in. Do you see it? Okay. Thank you, Ruby.
And on the circles right here, I can't do individual little angles on the side right there. I have to do an entire circle just because it's me.
Who else wants to show us their paper?
Okay.
Come on. Bring yours up too. Sometime today. Come on. Come on, Pokey. Do y'all see it? He did miss one. Do y'all notice anything about this?
They equal the same thing.
Look at Samuel's.
Mine are drawn backwards though.
Thank you, sir.
No. Thank you.
Okay, what are you noticing? What are you noticing? What thing is jumping out at you when you measure those angles?
They equal the same.
They equal the same. The angles that are in the same location on the other line equal the same thing. So like this, if this is 103, this one down here is also 103. They have a name. When they're in the same location, I need to wait till Tara gets back. I don't want her to miss this. So we're going to take a minute. Y'all, did I do row? I did for high school, but I didn't for junior high.
Nah, I want my leg all over you right now. I don't like follow Sam Hustle on Instagram.
Thank you, Renard. Let her in. Come on, so we can get on with this lesson. Okay, so we waited for you because I didn't want to say this word without you being in here, okay? So this angle and this angle right here that are in the same location, just on the other line. They're like if you took this and you cut it apart and you slid one down, they would line up on top of each other, right? This angle and this angle that are in the same spot are called corresponding angles. Corresponding angles. Corresponding angles are angles that are in the same location. Same location, just on the other line. Okay, we also need to do a little backtrack and talk about what this is called. Does anybody know the name of that line that's going across those two other lines? It has a name.
Vertices.
Nope, but good guess. Nope, it is a line, right? Because it has two, it keeps going and going. It starts with a T.
Transversal.
Transversal. That's called the transversal. Now, transversal just means a line that goes across other lines. That's all that means. Transversal is just a line going across other lines. Now, we know that if that's 103, that's 103. If that's 77, what does this one have to be? 77, because they are corresponding, right?
Doesn't that mean that the one across from 77 would also be 177 and then the one across from 77 would be
Yes, so let's talk about that. Remember last week when we learned about angles that are created when two lines cross each other and they have the angles that are across from each other have a special name? Remember that? This angle and this angle right here?
It's complementary.
adjacent?
Vertical. These two angles are called vertical angles, angles that are across from each other when lines.
Oh, I thought you were talking. Yeah.
And what do we know about this angle and this angle?
They're the same measurement.
They're the same. We're going to get to that in a second, okay? Hold that thought. So 77, this is also 77, right? 77 and 77. Now, what about these two angles right here? Do y'all remember this? These two angles?
Complementary.
They are supplementary. They add up to what?
180.
180. What's that called when you have two angles that are supplementary that are also adjacent? They add up to 180, but they are also touching each other. Search with a nail. Linear pair. Linear pair. They're a linear pair right here, right? Okay, we talked about that last week also. What does this angle have to be right here? 103. Now, how do we know it? Well, we know it by a couple of different ways. That angle and that angle are vertical, so it has to be the same. This angle and this angle have to add up to 180 because that's a linear pair. This angle and this angle have to add up to 180 because that's a linear pair, right? And then we can do the same thing down here. So what's this angle have to be? 103. What does this angle have to be? 77. They have to add up to 180, right? Now, we're about to talk about these angles here and these angles here and their relationships to each other. Okay? Now, we're doing it the very first time with parallel lines. And if the lines are parallel, these angles up here and these angles up here will be the same. If the lines are parallel. If the lines are not parallel, then those angles will not be the same. Like if you have two lines that just, random lines and you have a transversal, they still have corresponding angles. They're just not parallel to each other. I mean, they're just not congruent to each other if the lines aren't parallel. But we still say they're corresponding because they're in the same location. Okay? So I want you to draw you two more parallel lines and one more transversal. We're not going to measure any angles.
Wait, can I draw on the back?
Sure. This is for you. This is your paper. You can do it however you want to. I just give y'all blank paper because blank paper is easier to write on than lined paper.
Really, every time I write, like right now, I always somehow ending up writing diagonal. Just keep writing a straight line, unless if I have lines.
Okay. Now, once you have your parallel lines drawn and you have your transversal, let's write its name beside it so we remember what it's called. Your transversal here. Okay. I want you to number your angles. Let's start number 1 here. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. And we're just doing that so we know we're all talking about the same angles at the same time. Okay? So if I say angle 1, your angle 1 and my angle 1 are in the same location. Okay? They don't have to be numbered that way. That just makes it easy for us to discuss it. Okay, now I want you to consider your parallel lines as being like a bus. Okay? Kind of looks like a bus. They're like long, like a bus, right? Now you have angles that are inside the bus and you have angles that are outside the bus, right? Which angles are inside the bus?
3, 4, 5, 6.
3, 4, 5, and 6. Those are inside the bus. If we're referring to those angles and we're talking about their relationship with those two parallel lines, we would call them interior angles because they're inside the bus. They're inside the parallel lines.
Could be 3, 4, 5.
3, 4, 5, and 6 are interior. Yes. If we're talking about angles that are outside the bus, which angles are outside those parallel lines?
1, 2, 7, 8.
1, 2, 7, and 8. So if we're just talking about angles in their relationship to the parallel lines, we'll just say they're exterior angles. They're outside the bus. Exterior. Okay? So interior, inside the bus. Exterior, outside the bus. All right? But we don't just talk about their relationship with the parallel lines. We also talk about their relationship with the transversal. If you have angles that are on the same side of the transversal, we call them either same side, that makes the most logical sense, or another word we use is corresponding. Nope, that's the wrong word. My brain just stopped working.
My brain never works.
Consecutive. Consecutive. If they're on the same side, consecutive. You know, consecutive means in a row, right? So consecutive is if they're on the same side.
So 1, 3, 5, 7 would be
1, 3, 5, and 7 are same side.
4, 6, 8.
2, 4, 6, 8 are on the other
even
same
odds,
side.
Right.
Huh?
Even on. In this example.
In this example. But just in this example. Because they could be numbered anything. Now, when we talk about these different things, we talk about angle pairs. And what the angle pair relationship is. So we could have same side, also known as consecutive, right? I'm going to write both words. You will see both words, all. That's why we're using both of them.
Like,
You will see same side, interior. Now remember what interior means. Inside what?
So the, yeah.
Same side, interior angles. Now, which angles are on the same side? 3 and 5. So that's one pair, right? So angle 3 and angle 5. And then angle 4 and angle 6. That was supposed to be an and sign, and somehow my brain put a comma. So this is a pair here, and this is a pair here, right? They're two separate pairs. Does that make sense to everybody? Okay, what about same side, also known as consecutive, right? Exterior. So 1 and 7, and then 2 and 8, right? 1 and 7, angle 1 and angle 7, and then angle 2 and angle 8, right? Is that making sense to everybody so far? Does anybody have a question? Okay. Now we're going to talk about what if they're not on the same side. What if one is on one side of that transversal and one is on the other side of that transversal? Alternate. Right? So we would say alternate interior. So what are alternate interior angles? Angle 3 and angle 6. Or what's the other option? I mean, on the alternate interior. Angle 4 and angle 5, right? So angle 3 and angle 6, angle 4 and angle 5. And then we have alternate exterior. So which angles are alternate sides of the transversal but outside the bus? 1 and 8 and 2 and 7. So angle 1 and angle 8 and angle 2 and angle 7. Those are alternate exterior angles, right? Huh? You love this? This is one of my favorite lessons to teach. Okay, now let's talk about their relationship. If the lines are parallel, so like we know that these two lines are parallel because we made them parallel, right? These relationships, we call them these things even if the lines aren't parallel, but they don't have this relationship. But if the lines are parallel, there is a relationship between those sets of angles. So let's make up some value for this. And don't write this one on your paper. Let's just leave this one up here on my paper and you guys go, just leave yours blank. So what do we think this angle is about? We're just guessing.
25.
35. I say about 35.
Let's go with 35, okay? I don't know who said that, but I heard it. If that's 35, what does this have to be?
That's to be about
155. No, 145.
How do we find it?
minus 180.
180 minus 35, because that's a linear pair, right? So 180 minus 30 would be 150, and then minus 5 more, 145. What does, we all know you had it, Samuel. What is this one?
35.
How do we know?
Because the other one's 35.
What are these called? No.
Adjacent angles.
No. Adjacent means they share a wall.
Linear pair.
No. Vertical. These two are called vertical angles. I'm going to give y'all a quiz on that like next week. Yeah, y'all better figure that one out. Vertical angles.
Well, all you gotta do is remember, like, it's just going up, it's vertical. So like,
Yeah, vertical. If you're looking at the angle and you have to go up, sort of to see it, vertical. What's this one?
vertical.
Vertical to that one. So what is it? 145. Okay. What is this angle right here? How do we know it's 35? It is. So this one and this one. Remember what that word was? No, Samuel's right, and whoever over here was said it. What is it? Corresponding. They're in the same location. They correspond to each other, right? What is this one? Now, we know this for two reasons. Hold that thought, okay? So 145 here and 145 here, they're both corresponding to each other, right? But we also know this is a linear pair, right? Okay, what's this one? I meant where my pencil was, my bad. 145 because it's vertical to this one, but also these two are a linear pair, right? These two are a linear pair. And then what's this one? 35 because these are vertical, this is a linear pair, and that's a linear pair. Now I want us to look at these same side interior angles, okay? So look at angle 3 and angle 5. What do you notice about angle 3 and angle 5? They are consecutive, but what'd you say, Geronimo? They are same side interior. What do we notice about their measurements, though? They equal 180. What's that called when two angles add up to 180? They are supplementary. Now, are they a linear pair, though? That's tricky. Remember, linear pair, they have to be adjacent, and these are not adjacent. Like, this is like, I'm not adjacent to the library. We're close to each other. We're across the hallway from each other, but we're not adjacent because we don't share a wall. Adjacent to that room, not adjacent to the library, right? So, same side interior, these were supplementary, right? Is 4 and 6 also supplementary? Are they? Yeah. Okay, what about this same side exterior angles? 1 and 7. What do you notice about them? They're supplementary. What about 2 and 8? They're supplementary. So these same side angles, same side interior, same side exterior, are supplementary. Now, y'all, that doesn't mean every angle on the same side is supplementary. It has to be the ones that are interior or exterior, okay? So, like, if we pick just two same side angles, like 1 and 5, they're on the same side, right? But they're not interior or exterior. One's interior, one's exterior. They are not supplementary. They're corresponding, right? Okay, what about alternate interior? Angle 3 and angle 6.
It's over.
They're the same measurement.
But they're the same measure. What do we call that when angles are the same measurement? It's a C, but not corresponding. Congruent. They're congruent. They're congruent, right? Congruent. Looks like this. Congruent. What about 4 and 5? Are they also congruent? Do y'all see those? 4 and 5? They're congruent. What about these alternate exterior angles? So like 1 and 8. What about 7 and 2? So the ones that are alternate interior or alternate exterior are congruent, right? The ones that are same side interior or same side exterior are supplementary. Okay? Everybody good so far? Does it make sense so far? Remember, we call these that are in the same location, like 1 and 5, those are called corresponding, right? Corresponding when they're in the same spot. If they're across from each other like this, what are those called? Like 2 and 3. angle 2, and angle 3.
Wait, do we need to draw that 2 and 3?
I would probably write this down. So, vertical angles 2 and 3 are vertical, right? What other angles are vertical?
1 and 4.
Angle 1 and angle 4. What other angles?
5 and 8.
5 and 8. What other angles? Now, what do we know about all vertical angles in the world?
They're equivalent. Congruent.
They're congruent. They're congruent. Now, which ones are supplementary here? Which ones are linear pairs? Which ones are linear pairs? 1 and 3, 1 and 2, 2 and 4, 6 and 8, 5 and 6, 5 and 7, 7 and 8. Y'all see all those linear pairs? Okay. Now, if you pick two angles, like let's say 2 and 5, they're on alternate sides of the transversal. But one's outside and one's inside. They don't have a direct relationship to each other. You would have to do a relationship from 2 to an angle it has a relationship with, and then that one to 5. So like we could say, 2 and 6 are corresponding, and 5 and 6 are a linear pair. Y'all see what I'm saying? Okay, so I'm going to give you a little, let's see how much you learned here. How much time do I have?
About 6 minutes.
Oh, I'm doing great. I'm doing great. Pick a number.
24.
I'll go with that. Okay. These lines are parallel. This is 24 degrees. What is angle 8?
24 degrees.
See if you can figure it out. What is angle 8 and how do you know it?
It's congruent. It's extra.
Alternate exterior 24 degrees.
Or would it corresponding angles?
They're not corresponding. They're not in the same location.
Consecutive.
What is their relationship to each other? Okay, so let's break it down like this, okay? Everybody listening?
It's alternate exterior.
They are alternate because they're on the opposite sides of the transversal, right? Exterior because they're outside the bus. Alternate exterior angles. Now, our alternate exterior angles, what do we discover about those alternate exterior angles? What are they always? Congruent. They're always congruent. So if this is 24 degrees, what is 8? Congruent to it, which makes it 24 degrees, right? Okay. What is angle? Okay, what is angle 4? What is angle 4? How do we know? These two are vertical angles. So if that one's 24 degrees, what does this one have to be? 24 degrees. Also, what are 4 and 8 to each other? Because we already said this was 24 degrees, right? What are 4 and 8 to each other? Corresponding. Corresponding. That means they're in the same location on the other line. Corresponding. Okay? Okay. What is angle? So this one was 24 degrees. What is angle 2? It's adjacent to angle 1, which means what about them? They're supplementary and they're adjacent, which means we call them a linear pair. When they're supplementary and adjacent, we call them a linear pair. Okay? So these two are supplementary and adjacent, so it's a linear pair. By the way, what was that number? 156 degrees. So what is angle 6? How do you know that angle 6 is 156 degrees? It's corresponding to 2. What else? What is it to 8? Linear pair to 8. What is it to 4? They're supplementary because they are consecutive interior. You got to have both pieces. Consecutive interior. Inside the parallel lines on the same side of the transversal, right? Same side, or also known as consecutive interior. Okay, what is angle 5 based on angle 4? What is angle 5 based on angle 4? It's 24 degrees because angle 4 is 24 degrees and these are alternate interior. What's angle 3 based on angle 5? And how do they compare to each other? Consecutive interior or same side interior, right? What is angle 7 based on angle 2? 156, how do we know what it is? Alternate exterior. And anytime you have alternate, thank you. Anytime you have alternate interior or exterior, that's always going to be congruent. Anytime you have same side consecutive interior exterior, it's always going to be supplementary. Huh? That's a lot of writing. Hey, that is your paper for you to hang on to. Okay?